very different affordable housing programs. One on the plains of rural Wamego, Kansas, the other in a suburb of Dallas, Texas. The one critical thing these two programs have in common is that the lifetime operating savings provided by geoexchange heating and cooling systems made it possible for the homeowners to qualify for their mortgages. To see how this came about, let's take a look at how a typical geoexchange system works. Because the Earth absorbs and stores much of the energy it receives from the sun as heat, underground temperatures below the frost line remain constant at a point between 42 and 77 degrees Fahrenheit year-round, depending on where you are in the United States. Geoexchange systems can use this clean, renewable energy source to economically heat and cool almost any kind of home, and to provide domestic hot water. In its simplest form, a geoexchange system is made up of three components: a geoexchange heat pump located inside the building where it's protected from the environment and vandalism, a duct distribution system to channel the heated or cooled air to provide comfort control for the building space, and an underground heat exchanger made up of small diameter polyethylene pipe to extract energy from the earth for heating and act as a heat sink to store energy in the earth when cooling. Because the underground heat exchanger must usually be installed by either trenching or drilling, the initial cost of a geoexchange system is often greater than for more traditional heating and cooling systems, like gas, oil, or electric resistance heating. However, the monthly operating savings of a geoexchange system and low system maintenance can far outweigh the small monthly mortgage payment increase caused by installing the system. This savings translates into making more of the homeowner's income available to pay the mortgage, something that's especially important across rural America. PR&W Electric Cooperative and the Rural Housing Service developed a program in Wamego, Kansas, by which geoexchange systems and other established home energy efficiency technologies would be combined to not only manage the cooperative system load better, but also to help more rural Kansans with modest incomes qualify for RHS mortgages. A prime example of these ideas coming to fruition is the service's experimental 2,600 square foot Berger family house in Wamego, Kansas.
The tag of experimental bothered me some, and it is in some ways experimental, but it's really a package of technologies that have been available for some time. It's just the complete package of trying to put all these energy efficient systems together that's more or less experimental about the home.
RHS specified a comprehensive weatherproofing and insulation package and worked with the utility and HVAC contractor on the design and installation of a geoexchange system for its primary heating and cooling source and to provide domestic hot water.
The most unique part of it is the energy savings that you're going to get from a ground source heat pump. The advantage of using the earth rather than a propane tank, for example, or a natural gas line. We're merely just sucking the heat from the ground, which is replaced daily by the sun, and we can heat the home. In the winter or summer months, we can cool the home with the coolness of the ground. It makes your property worth more.
The geoexchange system uses a 2.5-ton water furnace heat pump with electric resistance backup heating set to come on whenever the exterior temperature drops below 0 degrees Fahrenheit.
It has low air volume. It's not moving a lot of air. And when you put your hand directly over a heat duct, you do get a little sense of air movement, but it's not to a drafty sense at all. And it doesn't have a chilling effect on the air like more extreme air movement would have.
In the winter, when it was so cold and there was all the 50 below, wind chill was 50 below zero, I know other people in new homes were cold, and we were not. You know, we didn't have any trouble with drafts, and everybody was real nice and comfortable.
The system's ground loop is a multiple pipe horizontal closed loop heat exchanger with 6 pipes per trench. The trenches were dug 2 feet wide and an average of 5 feet deep, and a total of 285 feet in length. 3 pipes were installed on the bottom of the trench and spaced to make sure that an appropriate distance was kept between the pipes to prevent heat buildup. Then each trench was backfilled with 2 feet of dirt, and 3 more pipes were installed before backfilling was completed. In all, 1,710 feet of polyethylene piping was used.
It's been kept at a level temperature basically the whole time we've been in it. And we haven't had a lot of up and down temperatures at all. When you come into the house, you have this temperature that we're in now, whether it's winter or summer, and it's is the temperature at which we're most comfortable. And the cost has been almost exactly as projected before we purchased the package.
The actual heating, cooling, and water heating cost for the first year operation of the house was $432. To increase system efficiency, a line runs from a de-superheater in the bottom of the heat pump to a supplementary hot water heater connected to the main 50-gallon electric hot water heater. Waste heat energy coming off the compressor at 180 to 250 degrees is salvaged and pumped to these tanks to provide supplemental heating to maintain water temperature.
One thing we do have is the hot water. We have, like you said, there's 6 in our family, and we don't ever run out. With 3 teenagers, they use a lot of hot water.
It's been great. We're getting really settled in. I've still got a lot of yard work to do, but the comfort level of this home has exceeded anything we've been in previously.
The Hillside Oaks development in East Dallas, Texas, is another classic example of the role that geoexchange technology can play in providing affordable housing. In fact, Hillside Oaks received one of only 43 awards given nationally this past year for building innovation under the Department of Housing and Urban Development's National Partners in Homeownership Awards program. The developer of this project is the Blue Bonnet Home Mortgage Corporation, a subsidiary of Blue Bonnet Savings Bank, both located in Dallas, Texas. Blue Bonnet's president, Kathy Cox, recognizes the importance of community and of the financial ability of homeowners to meet their long-term home operating costs.
Our target customer at the Hillside Oaks subdivision is a low to moderate income family, and in the Dallas area the median income is about $48,300, and we target about 80% of median in our sales efforts. So for those families, purchasing a home is very difficult. Keeping their utility costs down so they can stay in those homes and make their home payments also is very important. And the energy efficiency of the geothermal unit has certainly shown us that that's very helpful to those families.
With the goal of affordability in mind, the builder used a combination of geoexchange technology and tight home construction using structural insulated panels. Structural insulated panels made of several inches of styrofoam sandwiched between strand board dramatically increase the insulation value of the house and allow construction of a very tight, stable building envelope. Each of these homes can be optimally heated and cooled by a 2-ton Hydro Delta attic-mounted geoexchange heat pump with 1,000 feet of closed-loop heat exchanger installed in 2 250-foot wells.
The first time we turned the pump system on in the house, we basically had temperatures in the area around 35 degrees or lower for approximately 3 days. We turned the unit on. The house itself at the time was 56 degrees. That we account to the credibility of the panels themselves. The house heated up in approximately 7 minutes to 72 degrees. The unit shut off and didn't cycle again for almost 4 hours. Basically, we thought that the unit was either broken or it worked.
The combination of geoexchange technology and structural insulated panels allows each house to be heated and cooled for about $1 a day, less than half the cost of a standard stick-built house with a conventional HVAC system and standard insulation. Standard construction would also have required the additional expense of installing a larger 3-ton geoexchange system in each house. The bottom line is that lower utility bills for the life of the house mean lower homeowner debt limits, and smaller geoexchange equipment means a lower cost home that makes it easier for the targeted customers to qualify to purchase at Hillside Oaks.
If this had a normal system, I would not afford it. I would not be able to afford it at all.
Each of the geoexchange systems at Hillside Oaks will be sub-metered to verify actual operating expenses. So far, even the model home averages about $37 a month, even though its doors are frequently open thanks to heavy customer traffic.
It's very dependable, and I can really count on it to save me money every month, and it's very good, very, very good.
By installing the geothermal units in our homes at Hillside Oaks, we feel that it has made that entire subdivision one which will stand up through the test of time. When we went into this venture, we wanted to make sure that people were moving into neighborhoods, not just homes, and that those neighborhoods would be there for many, many years to come.
And what about the people who made the decision to install geoexchange systems at Hillside Oaks? Would they use this same technology if they were building a house for themselves?
I would absolutely put one in. I would not think twice about selecting a geothermal unit for my personal home.
The next home I build will be built out of structural insulated panels of some form, and I will have a geothermal heat pump. It's the best thing on the market.
To get more information about these and other geoexchange system affordable housing success stories, or to find out more about how this technology can be applied in your work, call the Geothermal Heat Pump Consortium at 1-888-ALL4GEO. Or visit their website at www.geoexchange.org.